Right, in this second video about solving unusual trigonometric equations, we have a question, quite a chunky 5-mark question from a 2014 paper, which is the calculator paper from the Trig section. Here we go. The question reads, express sine 4x in terms of sine 2x and cos 2x, and hence solve the equation sine 2x times cos 2x plus root 3 on 4 equals 0 for x belonging to 0 pi. Now this is like quite an unusual question. Now you may look at this initially and think, oh, this is definitely a tan 2x question, but you would be wrong. So let's look at the first part of the question. So it's asking us to write sine 4x in terms of sine 2x and cos 2x. What we need to be thinking of here is the double angle formula. Now the double angle formula is, as I hope you recall, and as you should recall, is 2 cos x times sine x. Okay, so hopefully it's not too much of a leap of the imagination that if I have to find sine 4x, that's going to be 2 cos 2x times sine 2x. So that's already 1 mark of the question. Now we have to use this information to solve sine 2x times cos 2x plus root 3 on 4 equals 0. Right, well, first of all, we would start by moving that root 3 on 4 over to the other side of the equal sign, and then noticing from the first part of the equation that sine 2x times cos 2x is half of what we've written here. Therefore, that's equal to 1/2 of sine 4x. And I hope you're starting to see where this question is going now. If I multiply both sides of the equation by 2, I get sine 4x equals negative root 3 on 2. And here we recognise one of those base angle sine cos values. Okay, so really what we're doing is we're solving the equation sine 4x equals negative root 3 on 2. So what we want to do is we want to solve this equation over negative root 3 on 2. Okay, so let's go through the sequence of steps, the dot point sequence that we need to solve this equation. First of all, if we look at the base angle, which base angle has a sine value of a square root of 3 on 2, and that is pi on 3. Next, let's have a look at the quadrants. So if we draw a little quadrant diagram, where is the sine value negative? Sine value is negative here and here in quadrants 3 and 4. Okay, and finally we need to readjust our domain. So if x is in the interval 0 pi, then of course 4x is going to be in the interval 0 times 4 pi times 4. So that's where we're solving the equation. Okay, so what we can do now is we can do our special little snail shell diagram, as I call it, okay, to figure out what is going on. So let's see if we can actually draw in that diagram. A little bit easier just to do it like this for me. Okay, right, then remember we're going to mark in those base angles which we're interested in. So we're looking at the related base angles to pi on 3, which are in the bottom quadrants. So the first one, of course, is going to be pi plus pi on 3, in other words 4 pi on 3, and this one is going to be 2 pi take pi on 3, which is going to be 5 pi on 3. Okay, now let's mark out where the interval starts and finishes. We're starting on 0 and going round to 4 pi. So let's start on 0 and let's start going round. 1 pi, 2 pi, 3 pi, and 4 pi. And that's where we finish. Now let's count up our solutions. We have 1 solution, 2 solutions, 3 solutions, and 4 solutions. Okay, so we know how to interpret this diagram. So that means that 4x is equal to the following values. So let's start from 0 and move clockwise. So 1 pi, 2 pi, 3 pi, 4 pi on 3. The next solution is over at 5 pi on 3. 5 pi on 3. The next solution is going to be one whole revolution of the trig circle around from 4 pi on 3. So if I add on 2 pi, which is 6 pi on 3, I end up with 10 pi on 3. And if we do exactly the same with this one, we add on 2 pi, 6 pi on 3, we end up with 11 pi on 3. Okay, and that is all the solutions. And to finish off, we need to divide each of these by 4. This one gives me pi on 3. 5 pi on 3 divided by 4 is 5 pi on 12. 10 pi on 3 divided by 3 is 5 pi on 3. Oh, excuse me, I wrote 3 there when I should have written 12. This one's 5 pi on 3. Is that correct? No, it's not correct. 10 pi on 3, excuse me, divided by 4 gives me 10 pi on 12. That's correct, 10 pi on 12. What have I done? Yes, 10 pi on 12, that's correct. Okay, but I need to simplify it, of course. And then finally 11 pi on 12. Sorry about that, it's a bit late. Brain's got a little bit tired. There we go. Alright, and there we have it. So the solutions to the equation are pi on 3, 5 pi on 12, 5 pi on 6, and 11 pi on 12. And there you have it. Okay, this is a slightly trickier trigonometric equation, but you can certainly expect slight curveballs like this to pop up from time to time. Okay, see if you can review that and try it again on your own.